In section 1.6, we're going to talk about relations and functions, and I want you to be able to identify the domain and range of a function, of relations and functions. So let's start out with some vocabulary words. First, a relation is a pairing of input values x with output values y. So we could have x comma y. The domain is the input values, so that would be x. And the range is the output values, so that would be y. Now, if we look at an equation, y equals 2x plus 1, and we say that x is 3, the domain is x. So that means the domain is going to be 3. And to find the range, we have to find y. So all we have to do is go to this equation, and wherever we see, we're going to say y equals, which is also your range, 2 times 3, just need to close that parenthesis, 2 times 3 plus 1. So when we put a value of 3 in for our domain, we're going to end up with 7 for our range. So our ordered pair would be 3, 7. Okay, next vocabulary word. A function is a relation, which we already defined as a set of ordered pairs, in which the first coordinate x is never repeated. Each element in the domain is mapped exactly to one element in the range. Okay, now we can find out if something's a function by using the vertical line test, and you probably remember this from Algebra 1 or geometry. A vertical line is a vertical line passes through or if a vertical line passes through more than one point on the graph of a relation, which again is a set of ordered pairs, the relation must have more than one point with the same x coordinate. So since there's more than one x coordinate, the x's repeat. The relation is not a function. And we'll do an example of that in a little bit. Mapping is a diagram that shows the relationship of the elements in the domain to the elements in the range. So it's a visual. Okay, let's look at some of this down here. To help us remember if x or y is the domain of range, you can put the x and the y in alphabetical order. So here's x, here's y, and then put domain and range in alphabetical order, and they map up to each other. Okay, so when you're listing the domain and range, there are some specific rules that you need to follow. You need to order them from least to greatest. Don't list repeats. And you use braces to enclose the elements. And you separate them by commas. Okay, so identifying the domain and range from a table. The domain, again, is just going to be the x values. Now, when the tables are sideways, the x is going to be on top. So we want to list them in order from least to greatest, which they already are. We're going to write braces, so 2, 4, 6, 8, close the braces. Whoops, that's kind of an ugly brace there. And the y's would be the cooking time. Order from least to greatest, which they already are. No repeats, and there are no repeats in this particular one. Okay, now we're going to go to the next one. I want you to be able to list the domain and the range from a table, from a set of ordered pairs, and from a graph. Okay, so now the domain here, we have 54, 57, 54, and 55. So order from least to greatest. Let's put that 54 first. And there's another 54, but I've already written 54 down once. I need 55, and then 57. Okay, now we're going to go to the range, which is the y coordinate. Order from least to greatest, we have a 3. So there's a 3. We have 2 4s, so we're only going to list them once. And we have a 7. Okay, when we do this with a graph, it may be easier for you to write all the ordered pairs. So let's just go from left to right here. That would be -2, 2. So -2, 2. And then we have a -1, 1. And then we have a 0, 0. We have a 1, -1. A 2, -2. And a 3, -3. Okay, so we're going to list the domain, and we kind of went from left to right here, so we already are in order. So we have, for the domain, we're going to list a -2, this takes care of that one, -1, 0, 1, 2, and 3. Then we're going to close it with braces. Now we're going to go, the range represents the Y, so we're going to list this as, we're going to go from least to greatest. So the least is -3. So -3, -2, -3, -2, -1, 0, 1, and 2. And then we're going to close with braces. Okay, let's flip it over to the other side. And how to determine if a function is a relation. That's the next thing that we're going to do. And it's a relation. A relation, which is a set of ordered pairs, is a function if the x's do not repeat. And it's as easy as that. You don't have to check the y's at all. So what I'm going to do is look at the x's. I'm going to cross off the y's because they don't matter. And here I have 2, 4, 6, 8. So that means, yes, it is a function. The x's do not repeat. Now we're looking at the set of ordered pairs. I don't have to worry about the y's. I'm just going to cross those right up. I see a 54 here, 57. As soon as I see a repeat, I can say that no, it's not a function because the x's repeat. Now this is where the vertical line test comes in. I can draw a vertical, and remember vertical is up and down, and if it hits more than one point, then it is not a function. So it fails the vertical line test. Okay, now we have a mapping. A mapping is just a visual that shows you can take points and you can list the domain and the range and then just draw arrows from the x coordinate to the y coordinate. So if we're looking at this one right here, this is not a function because I have the x's are repeating with the y's. This one is a function because there's only one arrow coming out of each x. So again, we don't need to look at the y's to tell if it's a function. We only need to look at the x's. So if I were to list this out, it would be 2a, 2b, 2c, 2 repeats. So you can tell if a relation is a function by looking at the number of arrows coming out of each element of the domain. If there's more than one arrow coming off from any member in the domain, the relation is not a function. All right, so let's look down here. We've got a couple of mappings. Here are the domains, which would be your x, and that's your range. I'm going to look right here at the 3. Automatically I see, or first thing off, I see that the 3 has 2 arrows coming off. So if I would list this as ordered pairs, it would be 3, -1, 3, -2. The x's would repeat. So it is not a function. X's repeat. I can still list the domain and the range, so those go in order from least to greatest. So the domain would be the x, 3 and 6. Well, it might be easier to do this. Let's list the ordered pairs up here. We have 3, -1. We have 3, -2. We have 6, -1. And we have 6, -2. Okay, so from least to greatest, again, we have 3 and 6 for our domain. And as you can see here, we have the 3's repeat and the 6's repeat, but we don't list the repeats when we name the domain here. So now we have, for the range, I have -2, remember least to greatest, and -1. We don't list the repeats. Okay, let's do this one without listing the actual points. So I can look here that 3 has 2 arrows coming off of it, so that means that it's not a function. X's repeat. The domain is 3, 5, 7, already in order for you. And the range is -1, 0, 9. Again, already in order for you. Okay, you have some questions on the other side to try.